Good afternoon, everyone. Today we are excited to present our project on the microwave oven embedded system. This project explores the application of embedded system in household appliances, focusing on how a microwave oven functions. We will discuss its different modes, embedded system components, and the programming aspect behind it. Let's define it. Now, here is an overview of our presentation. We will begin with an introduction to microwave oven, followed by a discussion on embedded system, their types and components. Then we will explore microcontrollers, microprocessors, and the tools required for development. Finally, we will discuss project specific components and their functionalities. Next. A microwave oven is a common household appliance that uses electromagnetic waves to heat and cook food. These waves cause water molecules in food to vibrate, generating heat through dielectric heating. This process makes cooking efficient and faster than conventional methods. Essentially, a microwave oven is a device designed to cook food quickly using microwave radiation. Now, we can talk about different modes of microwave oven. Microwave oven operates in multiple modes based on different heating techniques. The micro mode uses microwaves to heat food. The grill mode utilizes a heating coil for grilling. The convection mode incorporates a fan and heating coil for baking. Lastly, the start mode initiates the cooking process based on selected settings. Understanding these modes helping us appropriate how embedded system control different functionalities within the oven. Now, there is a point called introducing to C programming. Basically, C programming is fundamental to embedded system. It is a general purpose language used for writing firmware and system software. Some essential concepts including functions, variables, string, operators and control structure such as loops and conditional statement. Additional storage classes, arrays, and pointers play a crucial role in memory management, which is vital in embedded programming. Now, what is embedded system? An embedded system is a specialized computing system designed for a specific function within a larger device. Unlike general purpose computers, embedded systems are optimized for efficiency and real time operation. These systems combine hardware and software to control functions in devices such as microwave ovens, washing machines, and automotive systems. Now we can move forward to the types of embedded system. Embedded system can be classified into four main types. The one is standalone embedded system functions independently like calculators. Real-time embedded systems are designed for time-sensitive applications such as airbags in cars. Network embedded systems communicate over networks commonly seen in IoT devices. Lastly, mobile embedded systems that are used in portable devices like smartphone. Each type serves different practical applications. Here we add some different types of embedded system examples in the slide. Now, the next point is components of embedded system. An embedded system consists of several key components. The power supply provides the required voltage. The microcontroller acts as the brain of the system. Memory stores programs and data, while timers and computers handle event scheduling additionally. Communication ports allow data transfer and input output ports connect peripheral like sensor and displays. Here we mention a flow chart of that part. Now next we have to discuss over microcontroller. A microcontroller is a compact computing device that integrates a CPU, memory, and peripherals on a single chip. It is specially designed for embedded applications. Microcontrollers are highly power efficient and widely used in embedded systems to control various functions, such those in a microwave oven. Now next is microprocessor. A microprocessor is contrast to a microcontroller. Is primarily the CPU of computing system. Unlike microcontrollers, microprocessors require external memory and peripherals to function. They are commonly found in personal computers and servers, where most complex processing capabilities are required. Now, here is some discussion over the difference between microcontroller and microprocessor. The comparison highlights the key differences between the microcontroller and microprocessors. A microcontroller integrates all necessary components, making it ideal for embedded system. It contrasts a microprocessor focuses on computational tasks and requires external components. Understanding this difference helps in choosing the right hardware for an application. Now we move forward to the project requirement. For our project, we utilized several tools and components. We used the MPLAB X IDE for coding and debugging, the XC8 compiler to convert the C code into machine language, and PiximLab to simulate microcontroller based circuits. The microcontroller we selected for this project is the PIC16F877A, which supports multiple peripherals and embedded functionalities. Next, we have to discuss on MP Lab X IDE. That is an integrate development environment designed by Microchip Technology. It provides a graphical interface for writing, compiling, and debugging code for PIC microcontrollers. This tool simplifies embedded system development by supporting real-time debugging and simulation. Now we move forward to XC8 compiler. The XC8 compiler is a C compiler optimized for PIC microcontroller. It converts high-level programs into machine code that microcontrollers can execute. It supports ANSI standards and it's designed to optimize memory and processing efficiency in embedded application. Now, next is PiximLab. PiximLab is an embedded system simulator that allows developers to test their microcontroller based design virtually. It provides an environment to simulate PIC microcontrollers, reducing the need of physical hardware during the initial development stages. Now, here is an architecture diagram of PIC16F877A. The site presents the architecture of embedded systems. It outlines how different components such as microcontroller, memory, input device and output peripherals interact with each other to achieve the desired functionalities. Now next is PIC16F877A and peripherals. That means it is a 8-bit microcontroller widely used in embedded applications. Some of key peripherals included 16x4 C LCD for displaying message, a tactile switch for user inputs, a matrix keyboard for multi-button input, and built-in timers and interrupts for event handling. These peripherals enhance the functionality of the embedded system. Now next, 16 into 4 CLCD is a character LCD display module that can display 16 characters per line across 4 lines. It is used for user interaction by displaying message, system scouts, and input prompts. It can communicate with microcontroller via parallel or I2C interface. Tactile switch. A tactile switch is a small mechanical button used for momentary electrical connection. It is commonly found in embedded system for triggering actions such as system reset or mode selection. In our project, it is plays a crucial role to user interaction. Now next is matrix keypad. A matrix keypad consists of multiple switches arranged in row and columns, allowing efficient multi-button input with fewer GPIO pins. This component is often used for password entry and menu navigation in embedded system. Now the next point is interrupts and timers. Interrupts and timers are essential for handling real-time events in embedded system. Interrupts allow immediate response to external or internal events, while timers help schedule tasks and manage time delay. These features ensure efficient and accurate system operation. Now, next, in summary, the key peripherals used in our project include a 16 into 4 CLCD for visual output, a matrix keypad and a tactile switch for user input, timer and interrupts for event handling and communication part for data exchange. These components work together to create an efficient embedded system for a microwave oven. That concludes our presentation part. We explored the working principle of microwave oven, the role of embedded system, and the deployment process of our project using PIC F877A microcontroller. Thank you for the attention. Now we will practically deploy our project and the voice will be my group member Somallo Bhattacharya for the next process.
Here we can see the main.c file looks like this. The main.h file, clc.c file, clcd.h file, and the matrix keypad file, timers.c file, and this was all about the code which we have done. Now I will show the simulation of the code or the microwave oven in the Pixim lab simulator. So first of all, let me reload. You can see the microwave oven has been powered on, and we can see here the 4 types of mode on the starting screen. The first one is the micro mode, the second one is the grill mode, the third one is the convection mode, the fourth one is the start mode. Now to see the micro mode, we have to press the key 1. So now I will press the key 1. We can see the micro mode has been started and it uses a power of 900 volt. Now we can here set the time. To set the time, just press the keys below. Let us suppose we want a time of 30 seconds. So we press 30, and now to start it, press hash enter, or to erase we can also press star to clear. So now I will press hash to enter. We can see the fan has been started and the microwave oven has started to cook or heat. Now as the time, we can see to pause the microwave we can press the key 5. We can see here the microwave oven has been paused. To start we will press the key 4. We can see that it has again started, and to stop we will press the key 6. By pressing key 6 we have stopped and the original screen has been displayed, that is the starting one screen has been displayed. Now we will see the second mode, that is grill mode. The grill mode can be started by pressing the key second. As I have pressed the key second, it has been started. Here we can set the time. Let us suppose I want to set the time of 1 minute and 30 seconds. So to set the seconds I will press 30, and now for 1 I will press 0 1. So now the time has been selected, uh, entered, and to enter or start the oven I will press the key hash. So we can see the oven has been started again, and simply for to pause we can select the key 5. To again start we can select 4, and to stop and go back to the original starting screen we can press the stop button, that is 6. Now I will press the 6. It has been stopped. Now we will see the third mode, that is the convection mode. In convection mode is used to preheat the microwave oven. So now I will press the key third to enter convection mode. We have entered the convection mode, and in convection mode we need to preheat the oven. So for that we have to enter the temperature to preheat. So let us suppose I want to heat it at a temperature of 45 degrees. So I will enter the 45 from mm, from the keyboard or the matrix keypad, and now I will press enter to start, and we can see that the preheating is done for 3 minutes, that is 180 seconds. And now we can see the time, uh, it is taking 180 seconds to preheat. We can also press the reset key to go back to the starting to restart the microwave oven. So I will also tell you that how to restart. So here we can see it is a reset key. So when I will press the reset key, we can see the microwave oven is again starting on, and the original screen, that is the starting screen, has been displayed again. Now I will tell you about the fourth mode, that is the start mode. By pressing the start mode, the microwave oven starts and it heats for a time period of 30 seconds, and after 30 seconds it again stops. So let us wait for 15 more seconds and see what happens. And see, we can see the time up screen, and the original starting screen is being back again. So this was all about the project implementation and the project demo. And at last, I want to thank Emertxe for giving me this great opportunity and providing me great learning. Thank you.